Hello everyone and welcome. I am Sanidhi Nair. In this video, we'll explore the code base of CircuitVerse. So before diving into the details, let me outline today's agenda. So we'll start with an introduction to what CircuitVerse is. Then we'll discuss the technical structure of CircuitVerse, giving you insights into how it's built. Next, we'll go through the process of setting up CircuitVerse using GitHub codespaces. After that, we'll move to the main part of this video, a comprehensive overview of the CircuitVerse codebase, helping you navigate and understand its structure. Finally, we'll wrap up by discussing contribution guidelines, sharing best practices for collaborating effectively on this project. So let's get started with the first part. What is CircuitVerse? So CircuitVerse is an open source platform for designing and simulating digital logic circuits directly in your web browser. It's designed to be intuitive and accessible, requiring no additional software installations. So CircuitVerse is widely used by students, educators, professionals, and also hobbyists, making it a versatile tool for learning, teaching, and creating circuit designs. The mission behind CircuitVerse is simple yet impactful: to empower users to learn, create, and share their knowledge of digital circuits easily and efficiently. Now, let's talk about how CircuitVerse is built. It's structured to be both robust and efficient. So, the backend is powered by Ruby on Rails, providing a strong foundation for the platform. On the front end, we have JavaScript, HTML, CSS, and Vue.js, which powers some of the more dynamic parts of the UI. Testing and tools include Jest for testing, ESLint for maintaining code quality, and GitHub Actions for automated workflows. Package management is handled by Yarn, Bundler for Ruby dependencies, and NPM for managing node modules. So this well-organized structure ensures that Circuitverse is both scalable and maintainable. Let's now look at how to set up Circuitverse using GitHub Codespaces. So this is a cloud-based development environment that allows you to get started quickly and easily. So while this is one of the simplest ways to set up Circuitverse, there are other setup methods available in the setup.md file if you prefer. In this section, I'll walk you through the steps to get CircuitVerse running using CodeSpaces. Okay, so open up your web browser, log into your GitHub account, and navigate to the CircuitVerse GitHub repository. So after that, you click on the fork button in the top right corner to create your copy of the repository. After forking, go to your fork repository and click on the green code button. Select Create Codespace on Master. So this will initialize a CodeSpace instance for you. So once the CodeSpace launches, wait for the setup scripts to run. So these scripts will install the necessary dependencies automatically. Okay, once the script is complete, you will see a notification in CodeSpaces stating that the application is running on port 3000. So you click on Open in Browser to access CircuitVerse. Okay, so when you open localhost for the first time, you may face an error stating missing application.js. So to fix this, please keep reloading the web page until the site loads. It may take multiple reloads to get this fixed. After that, verify that the application is running correctly and explore its features. That's it. You've successfully set up CircuitVerse in GitHub Codespaces. Okay, so now let's dive into the core of this video, understanding the CircuitVerse code base. The code base can seem complex at first, but I'll simplify it for you. We'll explore the directory structure, where you'll find the main backend and front-end components, the key files, understanding their roles and how they connect, submodules, what they are and why they matter in this project, the tools and configurations used to streamline development. So by the end of this section, you will have a solid understanding of how the code base is organized, making it easier to contribute or debug issues effectively. So now let's start at the top level of the code base. So at the root, you will find several important files and directories. Here are the key ones to note. So the README file provides an overview of the project, including setup instructions and links to documentation. The gem file and the gemfile.log. So these manage Ruby dependencies similar to a package.json file for node.js. Then comes package.json, which contains JavaScript dependencies and scripts for tasks like building assets or running tests. Then Dockerfile and Docker compose.yml. These define the containerized environment, making it easy to set up the application in Docker. Then comes the contributing.md. So this is a must-read file for contributors, which outlines guidelines for contributing code and reporting issues. Then comes the setup.md file, which provides step-by-step instructions to set up the project locally. Okay, so the app directory is the heart of the Rails application and follows the model view controller, that is MVC architecture. So the controllers handles incoming requests and prepares responses. For example, it routes user actions to the appropriate logic. Then comes models, where it represents data and business logic. So if you're working with the database, this is where you will spend your time. Then comes the views folder, which contains templates rendered into HTML for users. Apart from MVC, here are other key subdirectories. So the assets houses style sheets, JavaScripts, and images. Then comes mailers, which handles email related functionality. And then comes services, which encapsulates business logic that doesn't belong in model or controllers. And then comes serializers, which defines how data is converted into JSON for APIs. Then comes policies, which implements authorization rules. And then comes JavaScript, where modern JavaScript code lives here, often managed with tools like White. Okay, so next up is the config directory, which contains configuration files for various parts of the application. So the first one is the routes.rb file, which defines the application's routes, mapping URLs to controllers in action. Then comes the database.docker.yml file, which contains database connection settings. Then comes the environment folder, which holds environment specific settings for development, test, and production. Then comes initializers, which contains custom configuration for libraries and gems. Then there is the white.json file, which configures white, which is used for managing front-end assets. Okay, the CV frontend view directory contains the view.js frontend for CircuitVerse. It's separate from the Rails backend to maintain a clear separation of concerns. So the key components include the SRC folder, which is the main directory for view components and logic. Then comes the white.config.ts file, which is the configuration file for white. And then comes the package.json file, which specifies dependencies and scripts for the front end. So the simulator code is currently written in jQuery UI and is still in production. This means the existing simulator relies on legacy JavaScript code. So the simulator view is an effort to rewrite the simulator using view.js. It is still under development and not yet enabled in production by default. So you may notice some code duplication between the legacy and the new simulator due to this ongoing transition. The simulator directory contains code for the circuit simulation feature, which is a core part of CircuitVerse. So here's what you'll find. In the SRC folder, the main source code for the simulator is found. Then comes the vendor folder where external libraries used by the simulator is found. And then comes the spec folder, which tests specific to the simulator. Testing is an important part of CircuitVerse, and the spec directory contains all the tests. It's organized into subdirectories for controllers, models, views, and more. So the main setup files are spechelper.rb, which sets up the test environment, and then the Rails helper.rb loads Rails specific configurations for testing. The DB directory or the database directory contains database related files. So in the migrate folder, the database migration files are for schema changes. Then in the schema.rb file, so this file represents the current state of the database schema, and the seeds.rb file populates the database with initial data. The public directory contains static files served directly by the web server, such as images, CSS, and JavaScript files. The robots.txt file basically rules for web crawlers, and in the simulator view folder, static assets related to the simulator is found. For contributors, the docs and the installation docs directories are invaluable. So they contain guides for setting up the project, troubleshooting issues, and using Docker or remote development environment. CircuitVerse includes several tools to streamline development. So the bin directory contains scripts for tasks like starting the server, managing dependencies, and building assets. The .rubocop.yml file enforces Ruby coding standards. The .eslintrc.js file defines JavaScript linting rules. The commitlint.config.js file ensures commit messages follow conventional guidelines. Before you start contributing, here are a few things to keep in mind. Avoid manually editing the API doc v1 directory because it's auto-generated. Don't modify submodules like CV frontend view unless explicitly instructed. Follow the guidelines in contributing.md file and the code of conduct.md to ensure a smooth collaboration experience. So that wraps up our walkthrough of the CircuitVerse code base. Okay, now let's go through the contributing guidelines step by step. So first, always create a new branch for your work. Make sure to name it clearly, referencing the issue number. So this keeps the main code base organized and ensures your work is traceable to a specific task or issue. Next, stage and commit your changes. So be selective, like only add files relevant to your work. This minimizes unnecessary reviews. And also when committing, follow the Husky commit message guidelines to maintain consistency across the project. Once your changes are ready, push your branch to your forked repository on GitHub. So this is where your work is stored remotely and shared with others. After that, open a pull request, use a clear title, and provide a detailed description. So if your work involves UI changes, include screenshots or videos to help reviewers understand the impact of your work. Finally, submit the PR and collaborate. Notify the relevant mentors and be open to feedback. Promptly addressing their comments ensures a smoother review process and helps your PR get merged faster. So, by following these steps, you'll make the contribution process seamless for everyone involved. So, that brings us to the end of this video. We've covered what CircuitVerse is, its technical structure, how to set it up using GitHub Codespaces, an overview of its code base, and the contribution guidelines. Thank you for watching, and I hope this video helps you get started with CircuitVerse. If you have any questions or need further assistance, feel free to reach out. So let's keep building together. Thank you once again.